So I have to one-up the people behind, before me, right? So this is going to be done through interpretive dance. I'm just kidding. You wouldn't want to see that, and I don't want to do it. So let's see. I have to give a call out to my good friend Ben. He trolled me last year from the stage, and so Ben, it's my turn to troll you from this stage. In fact, let's go one step further with that. I'm a huge Utah Jazz fan, so I just have to troll Ben. Have to troll Ben from the stage. He did it last year, so there we go. Okay, that's it. Last sports thing I promise. Actually, I don't promise that. Okay, so let's talk about entropy. So where are my speaker's notes on this? Hold on. That's interesting. Well, no speaker's notes. We're doing live. Just oh, there it is, presenter's notes. Got it. Crisis averted. Okay, so entropy is the measure of how much disorder there is in a system. Or another way of thinking about it is it's chaos, like empirically measured, right? So the way you can think about this in terms of just like chemistry, and you all didn't think I was going to do chemistry, but joke's on you, we're doing chemistry. You can think of it as like having like an isolated system that you have some sort of reaction in, that over time, one of the laws of thermodynamics is it has to get more disordered, right? So if things have to get hotter, right, because if there's more like kinetic energy inside of your system, then you'll have like molecules bouncing around that's more disordered, right? Or if things become crystalline, right, and have like a crystal structure, then it's getting more, it's having less entropy. So this comes back to the second law of thermodynamics. How many of you took thermodynamics in college? You can just see like the sullen looks on their face. It's like, when I was a wee child. No, I did not. Well, I did, and I didn't pass. So, to remind you what the second law of thermodynamics is, it states that the total entropy of an isolated system cannot decrease over time. So basically, it's saying that anything that happens, you can be guaranteed that over time it gets more disordered, right? It can't go the other way, or otherwise you're breaking the second law of thermodynamics. So I think a really good presentation of how this works is something like this, which I took off of someone's website, and I hope it's okay. If you throw a bunch of bricks, right, there's like zero chance that you're just going to start throwing bricks and it's going to make a house, right? Like it's impossible. So if I throw bricks, it's going to get more disordered as it lands, whereas if I picked it up from a stack, right, so over time it's getting more and more disordered. And the same thing can be applied to chemistry, right? Like you're not going to have some sort of reaction and it's going to end up more disordered than it was before unless you put more energy into it. So building materials don't spontaneously build houses, right? It's not like you drop building materials off and there's no contractor there, right? And they just kind of apparate into a house. It just doesn't work. Or else it'd be a lot cheaper and maybe we could finally solve the Bay Area housing crisis. Startup idea right there. Make sure you give me royalties. So here's kind of my point today. Your systems don't spontaneously become resilient without you putting energy into it, right? So just like how a chemical reaction cannot have less entropy, as you build more and more application, like more and more things on your application, it gets more disordered over time. How many of you have been maintaining your current React application for longer than a year? Fair number of you. How about 2 years? All right, so for you, let's just pick on the Netflix team because I know exactly what's going on over there. From year 1 to year 2, how did that go? Don't answer the question, I know the answer. I was part of the problem, that's why I know the answer to that question. It's just that as you build the same application over time, right, you just have more and more things tacked on and more hacks, and then like things get built on top of the hacks, right, and your system becomes more and more disordered. And as it gets more disordered, it gets what? It gets less resilient, right? And you start having more and more downtime, and you're having weird bugs that are hard to fix because you have this foundational component that has been broken for years, but yet you rely on the broken behavior sometimes, right? So systems over time get more and more disordered. no matter what, right? Actually, the entire universe right now is getting more and more disordered as we go. In fact, eventually, there will be the eventual heat death of the universe and we'll all die. So you, so this got dark. This got dark really quickly. Don't worry, we're millions of years away from that. You don't have to like go to your therapist and talk about it. I do, but you don't have to. So you might be wondering, who's this jerk on stage? Why am I talking about the heat death of the universe? This was me in Scotland with my lovely wife, who did not want to come listen to me today, and I do not blame her. I work for this tiny startup. You might have heard of it. It's called Microsoft. I used to work for Reddit here out of Salt Lake City. I'm from Salt Lake City originally, but as Ben alluded to, I'm from the exotic kingdom of Seattle presently. I used to work for Netflix and LinkedIn as well. And probably the reason why I would imagine most people here might know who I am is I do the React courses for front-end masters. So, go for front-end masters. So, front-end entropy. You, as front-end developers, are used to entropy. Even if you're not necessarily thinking about it, we have one of the most chaotic programming environments that's out there. Like, I'm going to say that maybe if you're like a satellite firmware architect, that you might have more entropy because you have to deal with things like, gravity and shit like that. We don't have to worry about gravity. But beyond them, like there's like satellite programmer, front-end programmer right there. We have to deal with hostile code environments all the time. That is to say that you have to write code and it has to run on so many different engines, and that's ridiculous, right? Your code has to work across like a fractal amount of HTML renderers, JavaScript engines, browser plugins, accessibility tools, hardware, phones, viewports. Like it just goes, and latency, like that's probably the biggest one right there, right? You have so many different environments that you have to work in, and your code has to be resilient to that kind of failure. Like you're kind of just used to it, right? It's kind of part of the job description at this point is like, can you deal with like, AJAX requests failing, and can you do retries? Like, how many of you had to do, like, how do you do an AJAX retry in an interview question? I have. And don't ask it anymore. It's a terrible question. Okay, sorry. Beyond different engines, you have to worry about things like, what orientation is the phone in, and just like temporary things like that. It's a fractal amount of things to worry about that you can never worry about all of it. And what's hard about it is our work is extremely sensitive to like the slightest variations, right? If you're too slow to the first paint, people bounce, right? If you load the wrong things first and you load like the things below the fold instead of above the fold, people are going to bounce. If you're too slow to be interactive, so someone clicks on a button and it doesn't work, they're like, oh, this is broken, and then they're going to go to your competitor. If a network connectivity times out, which you have like nothing to deal with, and like you don't handle that kind of failure correctly, people are going to bounce. And if your site is just ugly, I see you out here. I know some of the companies you work for. People are going to bounce, right? If it's unintuitive, it's a bad design, bad DX, like all these different things, right? There's so many ways that you can mess it up, and there's only a couple ways to get it right. And most of us have to deal with internationalization, right? Like I think there's a talk later about it as well. Like, let's talk about internationalization. I've done this now for 2 companies. Let's talk about all the chaos that just comes from dealing with different languages. German, right? I'm probably going to offend someone here. I'm just kidding. I won't. But their kenning in German is ridiculous, right? Like you have like 40 character long words, and it means like an entire sentence. It's like, when I was a child and I grew up and I had this feeling, and it's one word, right? And it's like, stop it. Or you have like Turkish diacritics that just go in every direction, and there's like diacritics on diacritics on diacritics, right? And it's like bleeding into your header. I say that because that's happened to me. Or meaning some sort of like design consistency across fonts, right? Because if you have like Cyrillic characters, then it like changes the look and feel of your website, and then maybe it looks different, and maybe it like means something dirty, like you don't even know, right? Or like Thai. How many of you had to do Thai before? Like they don't believe in white space. So they have all their sentences together, and it's just crazy. Or, oh yeah, sometimes you have to flip your entire website from right to left. But not all of it. We found that out on Netflix, right? Like so the scrubber still have to go left to right because they had Western VCRs. Like all this stuff is stuff that you, as a front-end developer, like, oh yeah, I've dealt with that. Yeah, no, that happened to me yesterday, right? And you don't realize that like, you have these kind of chaos in your systems. Or Chinese, right? Chinese having like these characters that mean like 13 things with all these different fonts, right? Like, and by the way, in fixing all of these different issues with all the different languages, you broke English again. So like you're kind of back to the beginning. So hopefully I'm demonstrating to this point is like you deal with chaos day in and day out, right? But how many of you have ever told someone, yeah, that works on my machine? No one's raising their hand, but see, like all in your hearts, you're like, me. Yeah, I mean, I have. I've told someone that this week. So I want to get into what is chaos engineering. So this is a DevOps term, and I'm kind of lucky now that I get to work for a company that does more like I focus more on DevOps things, right? I get to work with Kubernetes and Docker and all these kind of new fun toys. So I get to like go from like working my React application all the way up to like large-scale Microsoft deployments using Kubernetes. So right now, the hottest thing in all of DevOps is definitely chaos engineering, right? Like I feel like I'm hyping up like a band or something like that. Like you haven't heard of it, it's pretty cool, but. So chaos engineering, if you're not familiar with the premise of it, it's intentionally causing problems within your system, introducing chaos, introducing entropy into your system to see where things break. So I want to just give you a bit of an example of that. Imagine you have this kind of system that you're working on, and you have this MongoDB backend with a Redis like caching layer and all these various microservices that then feed into like the UI clients, and then you also have like another front-end service that you're worrying about that has React and Angular or something like that. Like I imagine most of you work with an architecture that's not too dissimilar from this, right? So imagine that you're working on the system and all of a sudden your front end goes down, right? Something that looks like this. So your Ruby service catches on fire. No one can imagine that happening. Which then causes all of your front end clients to break, right? But then you can see that the mobile clients are still working. You can kind of work backwards in your head. It's like, okay, cool, I imagine my front end service broke, so I need to go fix that. But you can have things that are much more insidious than this, right? You can have something like your caching layer catching on fire, right? And then it's going to work for a while after that, right? Because it's just going to start directly hitting your database. But after a while, all databases at some point have kind of their limits. And like once the MongoDB layer's out, then everything's on fire. And you assume because your database queries are coming back blank that you have a problem with your database, or like maybe you're being too heavy on it. But in reality, your problem was your caching layer, right? And you may not catch that unless you have proper monitoring. Right? And it's just kind of like this thing that is like, everything's on fire, it's like, oh, it's okay. Right? So I'm going to go back here for just a sec. So what is chaos engineering then? Chaos engineering is the idea of like, let's do this on purpose. Like, let's just like break things and then see what other things break. And that's kind of the premise behind chaos engineering, is so that if you intentionally cause the breakage, then you get to know what the problem is, and then you can see all the symptoms that arise from it. So you get to identify these like single points of failures, or like these sorts of latency cause these sorts of problems. And there's these things called the it's going to make me wait. That's dumb. Joke's on you. Okay. Thank you, Touch Bar. That was the first time it was useful. I am sorry. Apple's here. Okay. So would you rather be paged at 2 a.m. on a Saturday or 2 p.m. on a Tuesday, right? That's kind of the idea that I'm getting at, is like, you can cause your own failure, right, and see what happens, and then you can kind of sort yourself out around those things. And you get to know in advance, right? Intentionally breaking your system lets you handle the cascading failures during the workday. You already know what broke, right? And from there, you're able to work backwards, and you can kind of identify, because you all know that at some point, every one of your systems is going to break in some fashion or other. It's either going to be slow, or it's going to have exceptions or something like that. So by causing pinning the CPU or causing like failovers or things like that, you can kind of break those things in advance. So I guess the big problem here is if you're handling it at midnight, one, you don't want to handle it at midnight, and two, like you need to do the diagnosis first. And that's actually really the hard part, in my opinion, is like working backwards to figure out what actually broke. And if you cause it yourself, then you get to know. So you won't get paged at midnight if you intentionally break it before you leave, right? It's kind of the thought here. So Tammy Butow, who works for, I'm sure I'm saying her name incorrectly, but she works for a company called Gremlin, compared it to a vaccine. So a vaccine is like chaos engineering in that conspiracy theorists don't want you to do it. I'm just kidding. I'm just kidding. Okay, sorry, terrible joke, had to tell it. So, on the surface, it seems like it's a bad idea, right? Like, I want to be in a like doctor sprint planning meeting where they're sitting there like, you know, I wonder what happens if we intentionally gave people diseases, right? Like, who's sitting there like, that's a great idea, you have 2 week sprint to do it now, right? Or something like that. Like, on the surface, this is a horrible idea of like taking live disease and putting it in people. But now we kind of just like take it for advantage. Like, oh yeah, that makes sense. Like, then your immune system is used to handling these kind of problems. So, in the same sense, that's what chaos engineering is. This is like a vaccine for your system. And again, this is definitely Tammy's analogy that I'm co-opting here. Like, intentionally introducing these failures, so like introducing the disease into your system to figure out like what happens, right? And so that in the future that you're immune to these kind of side effects that are going to arise from this. So there's a thing called the principles of chaos.org. I definitely encourage you to take a look at this. It's definitely more ops focused, but it just got like my wheels spinning thinking about like how can we like bring this more into the front end, like a community that's used to dealing with this kind of chaos, right? Like I feel like we're kindred spirits with the DevOps people because we both have to deal with these chaos. We just deal with it in browsers and they deal with it on deployments. So chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production, right? Okay, so hopefully you're sitting there like, this all hopefully makes sense to you, like what is chaos engineering, but you're probably thinking like, okay, what do I do? This is kind of how I feel most of the time when I start thinking like, I have no idea what I'm doing. I feel like I'm just floating out through space. So I'm going to give you a few suggestions here of like things that you can work on. The first thing, I'm going to give you like the ops perspective. Like these are things that you should actually do in production. Like you should encourage your DevOps team if they're not doing it. If you are the DevOps team, then you should also be thinking about doing this as well. And like don't put this off, right? This is something that early startups should be thinking about as well because uptime is important. If your product is down, then you're not going to build trust in your product, right? So breaking it first before they see it broken is going to promote customer trust in you, right? So here's 2 ways to do it. One on, let's see, your left is Chaos Monkey. I imagine most of you have heard of that. If not, it is a open source project from the team at Netflix that causes these sorts of failures, right, on purpose. It's actually built into their new tool called Spinnaker, so if you're using that for deployments, just get it out of the box, which is pretty cool. The one on the right here is a commercial offering, which I think is worth every penny that you pay them, which is Gremlin. That like they break your stuff on purpose, right? But they have all sorts of awesome analytics around it, nice dashboards. So that's a paid offering that will do relatively the same thing for you, and they'll also kind of help you get going with it. So if you're on Azure, there's a thing called the Azure Fault Analysis Service. This is kind of it's kind of a freebie that we give you if you're on Azure. It's not necessarily as robust as some of the other offerings as well, but you can do things like chaos scenarios, right? Which are going to be things like the CPU's pin, I ran out of memory, or like this sort of latency is being injected, right? And they also will help you with the failover scenario, right? Most of us have had problems probably with failover as well, right? Like all of a sudden AWS region East is down, right? And I have to, I'm a multi-cloud, so I have to migrate that to Azure or something like that. And like that's a messy process, right? You should definitely test that before it happens to you. So these are a couple of things that Azure's fault analysis services. I dropped a little short link down there, cda.ms-CR, and that'll help you take a look at what that is as well. So I don't have a ton of time left, but I want to talk to you about something that I built that kind of brings us more into the front end. So that was more the DevOps perspective. There's also kind of the back end perspective of like, if I make a call to the database and it has a lot of latency, what am I going to do about it, right? And those are things that definitely like node developers and those people should be thinking about as well. But I want to bring this now into the front end. So I built a thing called Chaos Imp, which I'm still thinking about if that's what I want to call it. But normally during these talks, I have like a specific call to action. It's like you should go home and do this or try this. I'll be honest with you that my purpose here today is just really to inspire you to think about this because no one else is really thinking about it. I don't think. Most front-end developers I talk to are not really thinking about introducing chaos on purpose into their systems. So this is kind of my first crack at it, and I broke it. So I have nothing to give you today, but it's might be coming. Jem Young, who's in the audience, said like telling people to use your open source libraries, like check out my mixtape for developers, right? This is like check out my mixtape. It might happen. I might drop it. So I want to talk about what is Chaos Imp, what's the idea behind it, and then kind of like get you thinking about how you can do something like this. So you have a normal website like this is CSS Tricks. I bet you someone in here has it open right now. Right? Not necessarily this article, but probably the Flexbox article, because I'm assuming everyone laughing is that person right now. Like Plum is like, oh, sorry. And I was like, put their phone away. So this would be like a normal website. And the idea behind Chaos Imp is that during your development cycle to get all of those chaotic issues out of the way first, right? Because how many times have you gone out to production and realized that like the German translation is overflowing, or we didn't deal with this sort of like network problem, or these kind of things that like it worked well in your development environment because your development environment is like utopia, right? Like everything works, everything's fast, everything's instant, right? But when you get out to production, things are slower and things are in different languages and people have different browser extensions, right? So that's kind of the idea behind Chaos Imp is like maybe like 1 in every 10 requests, it just messes with you, right? So it translates the entire thing to German and it changes it to look like an iPhone and all of a sudden you're on 2G, right? And so during your development cycle, you're just going along and all of a sudden Chaos Imp decides to bless you with problems, right? Like if you've ever worked at a company that has Chaos Monkey, it's really the same thing, right? Like you're working on some server and all of a sudden like it's down. Like where did it go? And you just realize that Chaos Monkey's like, I don't like you today, right? So that Chaos Imp is like the annoying little brother to Chaos Monkey, I think. And just kind of going through these kind of different cycles of breaking things on purpose, right? So this one was like changing on its side and changing it to German and things like that. Or this one came back as Scottish Gaelic. I don't know how many of you are translating your sites into Scottish Gaelic, but this one is. It's not, I'm just kidding. That's just the Google Translate API. So this was kind of my prototype. It wasn't necessarily working all the time, so it's coming as a browser extension that you'll be able to put on and kind of like tune it out. And like, to be honest with you, it's really annoying. Like, I'm not really actually quite there yet of like what I want it to do, but so far it'll be tunable to those kind of things. Something else that got me super stoked about like what was going on in this kind of sphere was, I feel like I've been talking about Netflix a bunch. This is stuff that happened after I left. They have this pseudo-localization thing that I would like them to open source. So consider this your open source shaming right now. That just kind of throws everything at you, right? It adds a bunch of diacritics to things, and it still leaves it in a mostly like readable state. Like we all have like replaced numbers with letters and things like that, so we can all read that, right? But you see all the diacritics, and then it also does expansion to see if things kind of overflow into different things, right? So rather than doing necessarily a call to Google Translate, because that call is quite slow, this is kind of my next goal to re-implement that using this. And I was kind of like actually going through the motions of starting getting that to work. And then I realized that my good friend Tryggvi, if any of you have met Tryggvi, he's from Iceland. And now is working at Spotify in Stockholm, just wrote it like in a weekend because that's what he does. And it works really well. So definitely give this a shot if you're interested in working in things like that. The API for it is just really dead simple. You just say start and stop, and it works with React even throughout re-renders because it catches the events and actually goes through and reworks it for you. So this is my invitation for you at the moment to go through and think about like what kind of chaos can you introduce into your system? How can we get rid of this works on my machine thing? Because like that's really a problem like for every one of us in here, right? You don't want to think about things in terms of like outside of your development environment because you need to go fast, we need to ship bugs. Like no one here is doing it on purpose, right? No one's trying to like, I don't like Germans and so I'm gonna like make their UI look bad. I mean, someone might, but screw you. but actually going through and following through with these kind of different chaos patterns, taking that back-end community and really going through, and actually I'll read you here if I can go back to chaos engineering. Thanks, touch bar. It's really hard to see. Okay, so the chaos principles here that just kind of to think about is build a hypothesis around steady state behavior, right? Like you need to have like a scientific like hypothesis that holds up, and you need to measure like what's going better and what's going worse, right? Like if I translate this to German, that I won't overflow things, right? So you're observing specific behaviors and looking for things. You need to vary real-world events, right? So you need things to happen as if they're going to happen in production, right? Like so you are going to have German and Turkish users on your site. Run experiments in production, and like this is super important as well. Like it's good to check these things in development, but we're not optimizing for development, right? We're optimizing for prod, right? So make sure that you're looking at your real-world websites doing this as well. Automate experiments to run continuously. This is what I'm kind of trying to think about in the future. Like that makes sense for DevOps, right? Like introduce chaos into your production systems because you want your production systems to be resilient. But like, you also want this to probably be a part of like your CI and CD and things like that. So maybe having something to take screenshots or something like that. And then the other thing is you want to minimize the blast radius. You don't want this to affect customers at the end, right? So obviously don't pseudo-translate things before they go out the door. So this is my invitation for you at the end of all of this, is to think about how you can introduce chaos into your front-end systems and your back-end systems so we get rid of this problem of works on my machine. Thank you.